Hi guys, welcome back to Aisha.Academy. And in today's video, we're going to be going through the higher paper 1 June 2019 paper for GCSE Maths Edexcel. So let's get right into it. Okay, so this question was also in the foundation paper, but basically you have blue cubes, red cubes, and yellow cubes, and it wants us to basically complete the table. So it says that the number of red cubes in a box. The number of red cubes in a box is the same as the number of yellow cubes in the box, and it's already given us the probability of the blue cubes. So total probability always adds up to 1. That's a rule of thumb. So to work out the red and yellow probability together, we are going to do 1 minus 0.2, which would leave you with 0.8. Because the number of red cubes and yellow cubes are the same, we're going to divide this number by 2 to give us 0.4. So therefore, the probability of red is 0.4 and the probability of yellow is also 0.4. Then part B of that question, just zooming out so you can see the whole question. Part B basically states that there are 12 blue cubes in the box and it wants us to work out the total number of cubes in the box. So we know that 12 cubes is equal to 0.2. We know that total probability adds up to 1. So yeah, from 0.2 to 1, we multiply by 5. And so we're going to do the same on the other side. So that would leave us with 60 cubes in total in the box. So moving on to question 2, Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour sugar and 2 times as much butter sugar. She's going to make 60 biscuits. So it wants us to work out how much flour she needs. So if there are 3 times as much flour as sugar, we are going to do the 50 grams multiplied by 3. That's 150 grams. So we know that she needs 150 grams of flour for 15 biscuits, but we need to work out how much she needs for 60 biscuits. So we're going to do 60 divided by 15, that gives us 4. And so that number 4, we're going to multiply it by our 150, and that would leave us with an answer of 600 grams. It then goes on to say, Dion has to buy all the butter that she needs to make 60 biscuits. So she buys the butter in packs of 250 grams, and it says how many packs would she need. So we're going to work out how much butter she needs first. So it says she needs twice as much butter as sugar. So we are going to do 2 times 50, which would leave us with 100 grams. That's for 15 biscuits. So for the 60 biscuits, we're going to times it by 4 like we did before. That would leave us 400 grams. So she needs 400 grams, but if each pack is 250, then essentially she would actually need 500 grams of butter. And the reason why is because if she has 2 packs, that's 500 grams. So even though it's more than what she needs, it's better for her to have that surplus and have that extra than to not have enough at all. So overall, she would need 2 packs because 1 pack would not be sufficient. So question 3 says find the highest common factor of 72 and 90. So we're going to work out the prime factors of 72. So we could do it one way. Well, there's different ways you can do it, but one of the ways is split up as 36 and 2, circle that. Split up 36 into 6 and 6. Split 6 up further into 3 and 2 and 3 and 2. And I always circle the prime factors I find so I don't miss anything out. Then we're going to work out the prime factors of 90. So one way you can do it is 10 times 9. In the foundation paper, I actually did it another way, but it's good to see different ways. So 10 can be split up as 5 and 2, and 9 can be split up as 3 and 3. Then the next step we're going to do is when it comes to finding the highest common factor and lowest common multiple, it's easier when you put a Venn diagram in place. So we're going to now make a Venn diagram for the 72 and the 90. So whatever numbers they have in common are going to go in the middle. So we can see that they have a 3 in common and another 3 in common. They also have a 2 in common. So in our Venn diagram, in the middle, we're going to put the 2 3s and the 2 that they have in common. And then we are going to cross them out so we don't end up reusing them. And then 72 has an extra 2 and an extra 2. So they're going to go on the outside. And 90 has an extra 5, which would also go on the outside of in the middle part. So that's our Venn diagram complete. And then the last bit is to work out the highest common factor. You multiply all the numbers in the middle together. That's why drawing out the Venn diagram is a good way to help you to work that out. So it's going to be 3 times 3 times 2, which would leave you with an answer of 18. Then question 4. I'll zoom out so you can see it clearer. Question 4 says the diagram shows the plan, the front elevation, the side elevation of a solid shape drawn on a centimeter grid. And in the space below, it wants us to draw a sketch of the solid shape, give the dimensions of the solid on your sketch. Okay, so if something has a plan of a circle, right, your plan is like what you're seeing essentially from like bird's eye view, kind of not bird's eye view, but from front. Not from front, but from top view. So I'm gonna draw that circle again. So plan is like from the top, essentially. Then front elevation and side elevation, notice how they're both rectangular. So we can see if you've got a circle and a rectangle together, this is going to be your cylinder. So I'm going to sketch a cylinder. Now I need to actually put my dimensions on. So the first thing I need to do is work out the radius. So the radius is from the center point of a circle to the edge of the circle, right? If it's a centimeter grid and we've got 2 squares, then therefore this is 2 centimeters. I'll just put that's radius. Then the diameter would be 4 squares, so that's 4 centimeters. And then the height would be the distance from the top and the bottom of the front and the side elevation. So because that's 5 squares, we can know that's 5 centimeters. And that's the only dimensions we need. So that's it. Because if you look at this width as well, it's also 4 centimeters. And it's the same as the diameter, which also makes sense. Okay. So question 5, it says, I'll just zoom out again so it's clearer. So it says shape A can be transformed to shape B by reflection in the x-axis followed by a translation CD in the vector. So it says find the value of C and find the value of D. So it says first that it's reflected in the x-axis. So we are going to reflect our shape A along the x-axis. So we can see that it takes 2 squares to go from the bottom shape of A to the x-axis. So we're going to reflect that there. So that same point would be here. This point would also be here. And this point at top is 1, 2, 3, 4, 5. 5 squares. So it's going to be 5 squares from the x-axis, which would be here within the same plane. So that would be our shape A. Then the next part is we now need to translate it. So we can see that going from A to B, if we go down, I'll put it in a different color. So if you go down 1, now it's roughly on the same level. And then in terms of how many spaces we're going across, so that would be -1 down. In terms of how many we're going across backwards, it's 1, 2, 3, 4, 5, 6 spaces minus. So we know that in our x direction, it's -6. In our y direction, it's -1. Because remember, with vectors, you always put x difference at the top and y at the bottom. So therefore, C is equal to -6 and D is equal to -1. The next question says that a shop sells a packs of black pens, red pens, and green pens, and it tells us how many pens are in a pack, and it also tells us on Monday how many packs were actually sold. And it says 212 pens were sold, so how many green pens were sold in total? So we're gonna put black pens, red pens, and green pens. So if we know that 7 packs essentially were sold for the black pens and there's 2 pens in a pack, we are going to do 7 times 2, which means that 14 would be our ratio for the black pens sold. We're going to do that same calculation for the reds, but this time 3 times the 5, which would be 15, and similar calculation for the greens, which would be the 4 times the 6, which would be 24. Then we're going to add these parts of the ratios together, and your 14 plus 15 plus 24, you should end up with an answer of 53. So that's our total parts of the ratio. We know that 212 12 pens were sold in total. So we're going to do 212 divided by how many parts we have in our ratio to work out what one part is equal to. And that would be 4. So we know that essentially it's 4 pens for one part of the ratio. So to work out how many green pens in total were sold, we are going to do that 4 times the 24 for the green pens, and that should leave you with an answer of 96. Question 7 shows two rectangles. It says the length QR is 10 centimeters, and it says that BC is the same length as PQ. It also has given us the perimeter for ABCD as 26, and it's given us the area of PQR as 45 centimeters squared. And it wants us to find the length of AB. So the first thing is that we can work out the missing length of PQ based on the fact that it's given us the area, because we know the area is length times width. So we know that 45 is equal to 10 times, we'll call it x for now. So to work out what x is, our PQ, is going to be 45 divided by 10, which would be 4.5. And because we know that PQ is the same as BC, that's also 4.5. And the good thing with rectangles is the opposite length is always the same. Now, it says that the perimeter for ABCD is 26. So that means all these sides, this, added together should be 26. So, we can therefore say that 26 is equal to 4.5 plus 4.5, and we'll just call these x again, plus x plus x. So 26 would be equal to 9 plus 2x, and so 17 would be equal to 2x, so divide both sides by 2, so therefore x is equal to 8.5. So now we know these lengths, and because it wants us to work out what AB is, we therefore know AB is 8.5 centimeters. Question 8 says, work out an estimate for the value of root 63.5 times 101.7. So what we can do is we can round 63.5 up to 64, and we can round 101.7 to 100, because these are nice numbers. So the square root of 64 times 100. So the first thing that we're going to do is 64 times 100, because remember we're dealing with estimate, that's why I rounded them up. So that would be 6,400. Then the square root of 6,400. We know that the square root of 64 is 8, and then the square root of the 100 is 10. So essentially it will be 18. Then part B says 2.3 to the power of 6 is equal to 148, corrected 3 significant figures. And it wants us to find the value of 0.23 to the power of 6. So if something is to the power of 6, that means it's being multiplied essentially 6 times. So what we can then do is, if we know 148 is equal to 2.3 to the power of 6, then in terms of working out the 0.23 to the power of 6, we can essentially have our 148, and we can basically divide this by a million. And the reason why is because to go from 2.3 to 0.23 is the same as actually dividing by 10. If you now worked out a tenth to the power of 6, you'd end up getting 1 over a million. And so essentially you're going to end up dividing this 148 by a million, okay? And so by doing that, you would end up moving backwards 6 spaces, because a million has 6 zeros. That's a technique for that. So I'm going to stick the zeros on. So it'll be 1, 2, 3, 4, 5, 6. Okay. So it'll end up as 0.000148. Then the next question says we've got 5 to the power of minus 2. Based on your indice laws, if you have a negative power, it means that you are going to make this a fraction. So it'll be 1 over 5 squared. We know that 5 squared is 25, so it's 1/25. However, it says find the value. So we need to convert this into a decimal, which would leave us with 0.04. The next question involves multiplying fractions. So the first thing we're going to do is make them both top-heavy fractions. So the first one, to make it a top-heavy fraction, you would times the whole number by the denominator and add 1 to the top. So that would leave you with 3 times 2, which is 6, plus 1, which is 7, over 2. And the same thing on the other side, so 1 times 5, which is 5, plus the 3, which is 8, and then over 5. When it comes to multiplying fractions, you multiply the numerators together and you multiply the denominators together. So you'd end up with 56 over 10. It now says, give your answer as a mixed number in the simplest form. So first of all, 56 over 10, if we wanted to simplify it, we would divide both top and bottom by 2, which would be 28 over 5. To make that into a mixed number, you would end up with basically thinking of how many times 5 goes into 28. And so that would be 5 times with 3 over 5. So it will be 5 and 3/5. Okay, the next question says that the graphs with the equations 3y plus 2x equals to a half and 2y minus 3x is equal to minus 113 over 12. And they said they have been drawn. It says that using the graphs, find the estimates of the solutions of the simultaneous equations. So with simultaneous equations, they basically have a common x and y value. And when it comes to graphs of simultaneous equations, it's actually easier because it's basically where they intersect. So if we now zoom into the values, we can see that roughly the x point, I'll draw a line down. I'd say that's about, if that's 2.2, it's between 2.2 to 2.3. So we can estimate to say it's like 2.5. And then on the y value, oh god, it's a terrible line. Do that again. So we could say that it's somewhere between, so if this is minus 1.3, it's between minus 1.3 and minus 1.4. So again, we could say it's about minus 1.35. And the good thing about the mark schemes is usually they'll be like, they allow any value between, for instance, the x values 2.2 to 2.3. So as long as you're in between the range, that's fine. So we're going to say 2.25 and minus 1.35. Okay, so in the next question, it says a bus company has recorded the ages and years of people on coach A and coach B. And it says that here the ages of the 23 people are here. So it wants us to complete the table below. So median is your middle value, right? So the formula for median is the total number that you have, which is 23, add 1, divide by 2. So it'll be 24 divided by 2, which will leave you an answer of 12. So we're looking for the 12th value. So we'll count along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our median is 59. Our lower quartile is your total number plus 1 divided by 4, because it's a quarter. Median's like the half. Lower quartile is like the first quarter. So that's going to be 24 divided by 4, which is 6. So we're looking for the 6th value. So 1, 2, 3, 4, 5, 6. It would be there, so it's 53. Upper quartile is the like 3/4 value, like 75% of it. So you're going to do your 23 plus 1 divided by 4, which you did. You worked out a quarter of it, so times by 3. So now we're trying to work out the 18th value. So if we know this is the 12th one, this will be 13th, 14th, 15th, 16th, 17th, 18th. And that's it. So our upper quartile is 66. And then it now goes on into the next question. So it says, here's some information about Coach B. And it says that Richard says that people in Coach A are younger than Coach B. Is Richard correct? So there's different reasons you can give for this. I'll give some examples. One of the reasons that you could have given is the fact that, so I'll put that as one, the median of Coach A is 59, right? And the median of Coach B is 70. So that means on average, Coach A must be smaller. Must be younger. So your first point could be like the median of A is 59 whereas the median for B is 70. So on average, Coach A are younger than Coach B. Coach, not couch, B. Another point you could have said is because the greatest age of Coach A is smaller than the greatest age of Coach B. As long as you find something from the table to compare to back your point, that's what they're looking for. So that's that question. Then lastly, it says, Richard says that the people on Coach A vary in age more than the people on Coach B. Is he correct? So in terms of varying age, you're thinking of two ranges that you can compare for this question. I'm just trying to show the whole thing. So I'll write on the side. You could either, for this question, you could either compare the interquartile range or you can compare the actual range. So remember, interquartile range is your upper quartile, take away your lower quartile, and your range is your big value, take away your small value. So let's work out the interquartile range for A. So for A, I'll write it down. It's going to be the upper quartile, which is 66. Take away the lower quartile, which is 53. So that'll leave us with 13. For B, it will be the upper quartile, which is 73. Take away the lower quartile, which is 54. So that's 19. Okay. So let's look at the range, because that's not really stating or supporting Richard's answer. So now, in terms of the range, we can see that the range for A is the greatest, which is 79, minus the least, which is 41, which is 38. And whereas for B, it's 85 minus 42. So our range for B would be 43. So we can see that the interquartile range for B is bigger, and we can see the range is bigger. So Richard is incorrect. So we would write something, so you could either write either or. So I've given you or. So either that you explain based on your findings of the interquartile range or of the actual range. You don't have to put both because it's a 1-mark question. So they only want at least one reason as to why. So I'm going to go for the range. So I'll say the range for A is 38, whereas the range for B is 43. 43 is bigger than 38, so Richard is incorrect. You can say something along those lines. It doesn't need to be word for what I've said, but something along those lines. Okay, so let's have a look at the next question. So the next question shows spheres P, Q, and R, and it basically says that the volume for Q is 50% more than P. So if I say P's volume, for instance, is equal to 1, then the volume for Q is 1.5 because it's 50% bigger. And then it says the volume for R is 50% more than the volume for Q. So 50% more. So essentially that would be 1.5 times 1.5, or another way you could do it is work out half of 1.5 and add that on to 1.5, and that should leave you with an answer of 2.25 being the volume for R. So it says that it wants us to find the volume of the sphere P as a fraction of the volume of the sphere R. So if we know that the volume for the sphere P is, let's say we've labeled it as 1, and the volume for the sphere R is 2.25, that's it as a fraction. So we need to simplify this fraction. So I'm going to times both top and bottom by 100. So I get whole numbers. That's 100 over 225. I can divide both top and bottom by 5 to simplify it, and that will leave me with 20 over 45. And then I can simplify this further by dividing, again, both top and bottom by 5, which would be 4 over 9. Another way you could have worked out is if you automatically just did divide both top and bottom by 25. But if you needed to take that step further, that's absolutely fine. So that would be your final answer. Then next question says, given that n can be an integer such that n is greater than 1, we need to prove that n squared minus n is never an odd number. Okay, so if, let's say, we've got n squared minus n. So we could factorize this, and that would leave us with n bracket n plus 1. So if we're saying that n plus 1 is odd, so let's say n is even. So if we said n is even, then therefore n plus 1 would be odd, because for instance, if you add 6, add 1, you get 7. If you add 42, add 1, you get odd. So anytime you have an even number, you plus 1, you get odd. So if we now had even, which is our n on the outside of the brackets, multiplied by odd, if you ever have an even number multiplied by an odd number, you will always get an even number. That's a rule of thumb. So let's say now n is odd. So let's just test this theory again. So if n is odd, then n plus 1 would be even. So if we had odd on the outside of our brackets and even on the inside, we're still doing odd times even, which is even. So therefore, n squared minus n is never odd, because both of our answers have come out with even solutions. So you could do anything along those lines. Then question 14 says, find the exact value of tan 30 times by sine 60. So this is very important for you to learn your values of sine, cos, and tan for 30 degrees, 60. So you need to learn sine, cos, and tan for 30 degrees, 60 degrees, 90 degrees, 180 degrees, and I guess 0 as well. Off the top of your head, so please learn this. So with the tan 30, it would be 1 over root 3, and with the sine 60, it's root 3 over 2. So when you multiply this together, the top and the bottom would actually cancel out, so you'd be left with half. Question 15 gives us a diagram of this solid shape. So it's a cone on top of a hemisphere. It's given us the height of the cone, the base of the cone, and it's given us that the hemisphere has a diameter of 6. It says that the total volume of the shape is k pi, and where k is an integer, so it wants us to work out k. So essentially, we're just going to work out the volume of the cone and the sphere and this hemisphere, add them together, and that will help us work it out. So the volume of the cone, they've been kind enough to give us the formula, so let's substitute in the values. They've given us the hard part. So it will be 1/3 times r pi times radius squared. So our radius is half of the diameter, which is 3. So it will be 3 squared times our height, which is 10. I've put 3 cubed. So our 3 squared is 9. 1/3 of 9 is 3. And then 3 times 10 would be 30. So we got 30 pi for our cone. Then for our sphere, it's going to be 4 over 3 times pi times our radius, which is the 3 again, cubed this time. So 3 cubed is 27. If we were to do 27 times 4 over 3, you'd end up with 108 divided by 3, which is 36. So that would be 36 pi for our sphere. So now it's to add those values together. But before we do that, remember this is for the sphere. And we've got a hemisphere. Okay, so we need to divide this by 2. And that's going to be 18 pi. Then we're going to add our volume of our cone, which is 30 pi, plus the 18 pi, which would leave us with an answer of 48 pi centimeters cubed. So therefore, k is equal to 48. So now it says that there are 3 dials on a combination lock, and it says each dial can be set to one of the numbers 1, 2, 3, and 4, and 5. So it says the 3-digit number 553 is one way the dials can be set as shown. And it wants us to work out the number of different digits of different 3-digit numbers that can be set for the combination. So what we do is that in this case, the total numbers that you have, well, that you can use out of, which is 5 total numbers, because we've got 1, 2, 3, 4, 5, you cube that. That's how you work that out, because it's a 3-digit combination. So that'll be 125, because that's the number of different 3-digit numbers that can make from the set. And then to work out the part B, which says how many possible 3-digit numbers have 3 different digits. Okay, so before we were just working out a number of different 3-digit numbers, so that was your total combinations that you make essentially. But those that just have different digits, you would always do your total number, which is the 5, times 1 less than that, times 1 less than that, because we've got 3 combinations that we can make at most. Well, 3 numbers that we can put in one go, and that would give you an answer of 60. So these are shortcuts for these questions, essentially. Okay, so question 17 says, given that x squared ratio to 3x plus 5 is equal to 1 to 2, find the possible values of x. Okay, so one of the ways that we can work this out is by actually changing this to a fraction. So we can make this as x squared over 3x plus 5 is equal to a half, because the x is equal to 1 and the 3x plus 5 is equal to 2. Then we're now going to rearrange this to make x squared the subject, so we'll end up with 3x squared is equal to a half divided by 3x plus 5, well, a half times by 3x plus 5, because when you move that over, it comes times. So it's going to be 3x plus 5 over 2. And then the last bit is we are going to make that nicer, so that will be 3 over 2x plus 5 over 2. And then x squared minus, so we're going to make everything equal to 0, minus 3 over 2x minus 5 over 2 is equal to 0. I'm going to multiply everything by 2 because it's nicer than dealing with fractions. So I've got 2x squared minus 3x minus 5 is equal to 0. Aha, quadratic equation. We could try and factorize this quadratic. So we've got 2x in one bracket, x in the other. And then we need our two numbers to make 5 realistically, nicely, are 1 and 5, but one of them is going to have to be positive and one's going to have to be a negative. So we can put the 5 in here and the 1 in here. In terms of, because we're trying to make minus 3, actually, take that back. We're going to put the 5 there because that'll be too big. And so you would then be left with 5 here, 1 here. And so because we're trying to make minus 3x, we're going to make this minus 5x and plus the 2x that could make from if we expanded those brackets. So now we need to actually find the solutions, aka make each bracket equal to 0. So that would leave you with answers for x being 5 over 2 and x being equal to minus 1. So those are our two values for x. So 5 over 2, or you can write that as 2.5. Either way is fine. Then the next question is adding surds together. So we've got root 3 plus root 12, and it wants us to leave it in the form of a root 3. So therefore, this root 12, we need to change it where it's got a root 3 involved. So we know that 4 times 3 could be a combination, and we know the square root of 4 is 2. So it could be 2 root 3, because once you worked out the square root of 4, that would go on the outside of the surd. So now we've got root 3 plus 2 root 3. And I always say that adding surds is kind of like adding x's, like in algebra. So this would leave you with 3 root 3. And then in terms of the next question, we've got a fraction surd, and it wants us to leave it in the form of root b over c. So first thing that we can do is expand the brackets. So that will leave us with 1 to the power of 7, which is just 1, over root 3 to the power of 7. So now we've got this root 3 to the power of 7. Root 3 to the power of 7, well, 1 over root 3 to the power of 7, we can rewrite this as 1, and then because you're root 3, another way of writing that is 3 to the power of a half. If you've got that times the 7 on the outside, that's the same as saying 3 to the power of 7 over 2. So we can write it like that. Because you got 1 over it, if we were to write it, we could rearrange it as a negative integer. So now we've got this. And then for the next step is we can think of different ways of rewriting this. So one thing when it comes to indices is that if you had 3 to the power of a half, which we're going to need because it wants it in the form of root b, so essentially that's going to be our root 3, which is 3 to the power of a half. We need to think of what we can multiply, or aka what power we add to a half to get to minus 7 over 2. So to get from a half to minus 7 over 2, you could work that out. So you do our 7 minus 7 over 2, take away, so minus 7 over 2, take away a half. That would leave you with minus 8 over 2, which is minus 4. So we know that that could be minus 4. Then, in terms of rewriting that, so we've got root 3, because we know 3 to the power of half is the same as saying root 3. And remember, with negative indices, another way of writing that is 1 over 3 to the power of 4. So now we've got our root 3 over 3 to the power of 4. 3 to the power of 4 is 81, so you've got root 3 over 81. Question 19, we've got x squared minus 6x plus 1 is equal to it to do with completing the square, essentially. So with completing the square, your x squared and your x, you're going to divide the x bit by 2. So that would leave, and then in the brackets, you just put one form of x. And then minus 6x divided by 2 is minus 3. So then it's going to be your x minus 3 squared, because that's the form for completing the square. You then have to work out what 3 squared is, which is 9, but remember you always take it away from what it is squared. Then you then add the 1 on the end. So then you'd be left with x minus 3 squared minus 9 plus 1, which is minus 8. So then we've got that. Then the next step is, if we're finding the values, if we make the bracket equal to 0, x would therefore be equal to 3, which is our, well, a is essentially 3. We didn't even need to do that. A is equal to 3 because we already had minus in it. If it had x plus a, then you would say x is minus 3, if that makes sense. And then our b is going to be, again, positive a because it's already got the minus there. We've got that there. Then it says, hence write down the coordinates of the turning point of the graph. So the coordinates now, we need to make our bracket of x minus 3 equal to 0, which would be x plus, sorry, that would be x is equal to 3. And then to work out the y part, it's always the n part here, which is just minus 8. So that's a shortcut for working out those. Then next question, so it says h is inversely proportional to p is directly proportional to root t. So then in terms of writing this out, h, if you write in terms of inverse proportionality, you always involve the constant k. So it will be k over p because it's inversely proportional, and p is directly proportional to root t. So remember k, the constant, times whatever it's proportional to. So it says, given that h is 10 and t is 144 and p is 6, we need to find a formula for h in terms of t. So we need to work out what our constants k are. So in terms of the first one, if h is 10, we'll substitute that in. We don't know what k is yet, and we know p is 6. So to rearrange this to work out what k is, we'd end up doing 10 times 6, so k is 60. And then here, p is 6, and this constant k, we don't know it, but we know that t is 144. So the square root of 144 is 12. So 12 is equal, 6 is equal to 12k, so 12 times k. So then k would be equal to 6 over 12, aka a half. So we know that k is 60 and k is a half, or you could write it as 0.5. So to now work out the formula of h in terms of t, what we now need to do is substitute our p here for whatever is equivalent to t, because then we're involving h and t in an equation together. So then that's going to leave us with h is equal to k over root t. We worked out what the first k was, which is 60. The second k was 0.5 root t. So then 60 divided by 0.5 5 would leave us with an answer of, well, we can actually just times both top and bottom by 2 to make them nice numbers. So 0.5 times 2 is just 1, so the bottom's just root 2. And then 60 times 2 is 120. So that's the simplest form of writing h in terms of t. So 120 over root 2. Then the next question has given us functions for f and g, and it wants us to find the inverse function of f. So basically, what I now do for working out inverse functions is I first of all replace my f of x for y. So I've got y is equal to 3x minus 1. Then I now swap the x's and y's. Now I'm going to rearrange this to make y the subject. So I'm going to end up with x plus 1 is equal to 3y. X plus 1 to the over 3 is equal to y. And then I now replace my y with my f minus 1x. And that's how to work out inverse functions. So f minus 1x is equal to x plus 1 over 3. And then the follow-up question says, given that fgx is equal to 2gfx, show that 15x squared minus 12x minus 1 is equal to 0. So this is all to do with your composite function. So I always think of when you're putting the letter inside, it's kind of like the baby inside the mother. So we're putting our g into our x for f of x. So it's going to be rewritten as 3 bracket x squared plus 4 minus 1, which would then expand the brackets. You'd end up with 3x squared plus 12 minus 1, which would be 3x squared plus 11. And then for the 2fgx, well, first of all, I'll just let you see the equations. For our 2fgx, we're just going to work out what gfx, no, not 2fgx, 2gfx. We're going to work out what 2gfx is first, which would be replacing this for the x part there. So then that would be 3x minus 1 squared plus 4. So we need to expand our brackets. So we've got 2 brackets. So expanding our brackets would leave us with 9x squared minus 6x is also implied plus 1. And then remember the plus 4 as well. So this is from the expanded brackets and then the plus 4 that carry down. So this would be 9x squared minus 6x plus 5. Remember, multiply it by 2 because we need to work out 2gfx. So then that would leave us with 18x squared minus 12x plus 10. And then remember, this is equal to fgx. So this is all equal to 3x squared plus 11 that we worked out before. We're then going to move all this over to the other side to make it equal to 0 because there's fewer things on that side, so it's easier. So that'll leave us with 15x squared because of the 18 minus 3, minus the 12x, and then 10 minus your 11, which is minus 1. Oh, not minus 11, minus 1. And that's showing that. And then the next question, it says that there are only R red counters and G red counters, and it says a counter. By the way, the last question, guys. So it says that a counter is taken at random from the bag. The probability that the counter is green is 3/7, and the counter is put back in the bag. It says that 2 more red counters and 3 more green counters are put in the bag, and it says that a counter is taken at random from the bag. Says the probability that the counter is green is 6 out of 10. So it wants us to work out the number of red counters and green counters that are originally in the bag. So if this is our probability of it being green initially, then we can write this as 3x over 7x. Because remember, this is a simplified fraction of the probability. So the x's actually shows the actual numbers of counters. So that's initially, right? Then later on, you have 2 more red counters and 3 more green counters added. So that'll be 3x plus 3. And then it would be 7x plus 5 because you've got 2 plus 3, so 5 counters being added on. Then obviously now we have this. So our 3x plus 3 over our 7x plus 5 is equal to 6 out of 10. No, sorry, 6 out of 13. So what we're going to do is we are going to rewrite this. How we could rewrite it is if we cross multiply. So cross multiplying would be multiplying this numerator by this denominator, this numerator by that denominator. So that would be 13 times the 3x plus 3 equals to the 6 times the 7x plus 5. Expand your brackets, so you end up with 39x plus 39 is equal to 42x plus 30. Then we are then going to collect the x's together, collect the numbers together. So if we take away 39x from both sides, we'll end up with 39 is equal to 3x plus 30. Then take away 30 from both sides. And that would leave you with 9 is equal to 3x. Divide by 3, x is equal to 3. So now we know what x is, we can actually work out the number of green counters and the number of red counters. So it's going to be our 3 times our 3 for the green counters, and the total counters we know would be our 7 times our 3. So that's going to be 9 over 21. So we therefore know that we have, which I'll just zoom out so it's clearer, and so you can still see the fractions. We therefore know that we have 9 green counters, and then to work out the red ones, we're going to do the 21 minus 9 because 21 is our total, and that would leave us an answer of 12. So we've got 12 counters, and that is your final answer. So that comes to the end of this paper, guys. I hope that was useful. Please comment down below if you have any video suggestions or anything you would like. Stay tuned for more content, and thanks for watching.